Hello everyone, I'm Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video is an actual solution to Day 16, Part 1, 2021 Advent of Code. The problem is called Packet Decoder. And if you did see or you see my Part 0 video where I just throw up my hands and go, I don't understand part of the problem, then yeah, that explains what happens when you're tired and working hard and bugs get introduced into your system that you're not expecting to see, and you overcomplicate matters because your brain isn't working right. So that's what happened in the first part, part 0, where I basically almost got a solution. I got all of these working, but I couldn't get the actual solution working. My puzzle solution is 906, but here we can talk about that in the code now. So the whole point is you turn hex code into binary, and I did do it more cleanly before the meltdown, and then of course there's a lot to clean up here, but it works, and it's not flashy. It's just journeyman. It gets the job done. That's all you need sometimes. You don't always have to come up with cool ways to solve problems that you come up with on a day-to-day basis. But if you do, that's cool. So turn hex into binary, and then read the codes that are coming in, right? Read the packets. So read for this guy, the first 3 bytes, then the next 3 bytes, and then there's a bit to determine, well, depends on this. If this is a 4, then you read in 5-bit increments. And then you basically concatenate the whole string together, turn it into an integer, and you have yourself the literal representation of what packet 4 means. But every other value goes through a different rule set. The same rules apply for the start here. The first 3 bits are for the packet version. The next 3 bits are for the type ID. But then now here you have an I value, which is a 0 or a 1, and then the rules are different for the 0s or the 1s. If it's a 0, then it's 15 bits, and then that tells you how many bits of code are coming after it, and then you do sub. Then you have to do basically recursive algorithms. You have to call the function again to get this part out, and then to get this part out, and then you're done with that sub packet, and so forth and so on. And the same with others on this side. If it's a 1 here, these values just tell you how many packets come after. And I was really hung up on this. Like, why are there so many extra zeros? And it turns out I was just worrying over nothing, as you'll see in my code, or if you will go back to my video. I got so hung up on trying to understand why there's so many extra zeros that it turns out it doesn't really stinking matter. So that was just me, again, just being tired and overthinking. Okay, so in the previous video, I do show you that all of these things come up proper. So like all of these do give a correct answer, and they definitely do now. And so let's take a look. So like my big data gives me my answer of whatever it is I said, 900 and something, and boom, 906. Oops, I have a printout. 906. I got hung up thinking that this giant string of data was like more than one transmission, or if you want to think of more than one string of data. I got hung up going, how do I know where one ends and another begins? And not realizing that this is just one big giant string and not multiples, because I was thinking, oh, maybe the B means this ends and then a new one begins. Oops, oh boy, I don't want to change that. Okay, so that would be brutal. And so the whole thought process was, again, and again, I only did this when I was thinking I was doing something wrong, or whatever. And so I take my data, I convert my data, which is in hex, into full binary. And so if you run this, you can see it's a string. So I get a whole bunch of zeros and ones. And then I have the function that does all the work, and then I just call it. And if I trust my recursion, then at the end of the day, my value will hold the correct response, and then the index, in case there is another one that comes after, maybe there is, maybe there isn't, then that index value is stored. And normally, a lot of times, what I do as a programmer when I'm setting up a recursive function is that I create what I call a public-facing function and a private-facing function. And so, like in this case, this is kind of superfluous here. Like this index value kind of doesn't matter to the end user, only the value matters to the end user. And so what I could do here is just kind of create this where I could just set up the public facing function, because doit is the terrible function here. So I'll call it def and I say get total packet version number total, get total packet version, something like that. And then I can pass along an index. And then in this case here, I can just, this is where I can call the doit. And this is where I could just say return value. And so for something like this, I guess I don't even need to pass in the index here. I could just say, just get total packet versions. And so then I could use this to print. So this function gets called the public function that doesn't take into account any of the stuff that's going on under the hood, how the recursion is truly working. And then it gets what it needs to get from the true recursive function and then just returns back the only part that matters. Let me just make sure that I still get 906 out of this, and I do. Okay, so but everything else is pretty straightforward because I have the binary string, and I just say, okay, first when I know I'm starting a packet, that get the first 3 bits, get the next 3 bits, that's the packet version, that's the type ID, and then so that's 6 bits. And if the packet type is a 4, then do my work here, go group by group by group and add everything together to figure out what's going on, what the number is, and then I'm storing the literal value. So when I hit this return, I have the packet version, I have the packet ID type, and I have the literal value. Since I don't know what part 2, I still don't know. I haven't looked yet because I don't want to ruin my day at this point. Part 1 ruined my day last night. So, but if I need it, I have that data here. And otherwise, if it's not a 4, then I go through and I go, hey, that extra bit, is it a 0? And if it is, then I do this work. And if it's a 1, I do this work. And this is where the recursion comes in, because there's no recursion in the literal case, but there is in this case. And so if that bit, the next bit is a 0, then I go, oh, okay, then I know there are a number of bits that have to sum up, and I have to basically continue until I hit that number of bits. So I say, okay, so I call it recursively, and then I get returned back, and I go, hey, these things come back in packets of 11 or 16. And so they're going to total up to whatever they need to total up to, and eventually when they do, then I return back. But I'm maintaining the total packets as I go. And so because this problem is asking for, what are the packet versions, the sum of all of them. So and basically it's the same idea for the other part. Instead of looking for like the length of the packets, we're just looking for a specific number of packets. And I just go, and then return back. And it's all recursive. So, so this thing can call this thing, and this thing can call that thing, and this thing can call that. It's all, it's all crazy how that all works together. But that's recursion for you, and it all works out to get me the answer I'm looking for. So that covers everything in this video. I'm happy to have a part 1 solution, and it didn't cost me more of my sanity than it already had. So if you have any comments, definitely ways to improve this. But I would say that for cases like this, and maybe I'm wrong. Please correct me if I'm wrong. That it's better to I feel like it's better to have code that you could comment and is pretty straightforward for how to decode than it is to be fancy and write all these one-liners and things like that and just try. I could do this in 3 lines of code and go, well, yeah, but what if the format changes, or what if there's a lot that can change with this kind of data and this kind of stuff that you're processing, and so it makes sense to me to kind of go back and do this. Maybe that's just me being naive and not having experience with this kind of work. I don't know. But thanks for sticking it out with me as always here on the YouTubes. Have a nice day, everybody. Take care, and I'll hope to see you in part 2. Hope to make part 2, and I'll see you then or in another video. Take care.